Okay, picture this. Imagine holding a completely normal, honestly kind of boring rock in the palm of your hand. On the outside, it looks like absolutely nothing special. But hidden inside that dull exterior is, well, an extraordinary power. I'm talking about copper. It is the absolute hidden hero behind practically everything in our modern lives. From the mobile phones we're always scrolling on, to the electric cars hitting the streets, right down to the massive electrical grids powering our entire cities. Welcome to this explainer. Today, we're going to trace the unbelievable, literally millions of years in the making journey of copper. We're going to see exactly how a rock buried deep underground goes through this massive, explosive, and frankly crazy chemical transformation to become the vital lifeblood of our modern world. So let's dive right in. Here is our roadmap for today. Unearthing the hidden hero, blasting and digging deep, oxide ores, the acid bath, sulfide ores, the bubble bath, purifying with fire and electricity, and finally, shaping our modern world. And I want you to keep this one big question in mind as we go. How does a completely normal, boring rock end up powering the smartphone in your hand? You know, you look at a rock, then you look at your phone, and it feels like magic. Actually, scratch that. It's not magic. It's an incredible feat of human engineering and extreme, mind-boggling industrial scale. Let's start right at the very beginning. Part 1. Unearthing the hidden hero, searching deep underground. Before a single shovel hits the dirt, geologists spend months testing soil samples. They use highly advanced methods to figure out if there are ancient copper deposits hiding down there, and more importantly, if there's enough of it to actually justify a massive mining operation. Which leads us right to part 2, blasting and digging deep, the violent extraction. To get to the copper, miners have to carve out a massive, bowl-shaped open-pit mine. And guys, the scale of these pits is genuinely jaw-dropping. It's a huge logistical nightmare right out of the gate. Just look at this number, 100. Before miners can even touch the copper-rich ore, they have to strip away the top layers of useless dirt. In some places, this useless dirt is up to 100 meters deep. To put that into perspective, that is the height of a 30-story building. You literally have to move a 30-story skyscraper's worth of solid dirt just to reach the starting line. It's wild. Once they finally hit the rock, the true extraction begins, and it is honestly thrilling. These massive drills bore about 130 holes straight into the hard rock, each 16 meters deep, which, by the way, is like a 5-story building itself. They pack these holes with nitrates and explosives, but they don't just blow it all up at once. They detonate them in a highly controlled sequence. Check out this precision. There are exactly 2 milliseconds of gap between each blast. From a distance, that tiny little delay literally makes the Earth look like it's breathing, heaving up and down before shattering the rock into pieces. As the dust finally settles, the raw copper ore is revealed. But get this, the rocks sitting in that rubble, they contain less than 5% copper. Over 95% of what you're looking at is just useless rock. So heavy machinery swoops in, scooping up 80 tons at a time, loading it into mammoth dump trucks that stand 7 meters tall. These mechanical beasts carry a massive 400 tons of material right out of the pit in a single trip. So here is the absolutely crucial point where our story splits. Once those trucks leave the pit, the rocks go down 2 distinct paths. You see, nature hides rock copper in 2 completely different types of rock, oxide ores and sulfide ores. Because their chemistry is totally different, the extraction methods couldn't be more opposite. Let's break both of them down, starting with the oxides. Part 3, oxide ores, the acid bath, or, as it's known, the silent drip. Unlike that explosive loud mine we just left, this process is incredibly quiet, very slow, and relies on chemical leaching instead of brute force. Here's how it goes step by step. First, millions of tons of shattered oxide rocks are stacked into huge piles across hundreds of meters. Then, instead of crushing them, a continuous, thin stream of sulfuric acid is dripped right over the top. Slowly, over several weeks, this acid seeps deep into the pores of the rock, chemically dissolving the hidden copper. Eventually, this beautiful dark blue-green liquid slowly drips out from the bottom. That vibrant liquid, that is carrying our copper. It's collected in massive vats for the next step. And the visual transformation here is just unreal. They take that blue-green liquid, add organic chemicals to bump up its density, and pump it into huge tanks filled with thin metal sheets. Then they zap it with an electrical current. Over just 10 days, the electricity forces the copper particles to separate from the liquid and bond to those metal sheets. Pull them out 10 days later, and they've grown into 2.5 centimeter thick plates of nearly 100% pure copper. It's a completely silent, almost elegant process. But what about that other type of rock? Part 4. Sulfide ores, the bubble bath or froth flotation. If the oxide process was a quiet acid bath, sulfide extraction is an aggressive, loud, messy bubble bath. This is a marvel of chemical and mechanical engineering. Getting copper out of sulfide rock takes serious elbow grease. Step 1. The wet rocks are thrown into massive tumbling machines full of heavy iron balls that literally smash the rock into a fine, wet mud. Step 2. They add specific chemical binders to the mud, chemicals designed to aggressively stick only to copper particles. Step 3. Pump this mix into huge water vats and inject thousands of air bubbles. Thanks to those binders, the copper grabs onto the bubbles and floats straight to the top. Finally, step 4. A thick, soapy froth forms, holding the copper. They just skim this froth right off the top. But hold on, here is the catch. Unlike the oxide process that gives us near 100% pure copper sheets right away, this sulfide froth is just a starting point. That froth they skim off, it's only about 30% pure copper. The other 70% is still just junk and rock impurities. So while the bubbles separated the bulk of the waste, we are nowhere near finished. Part 5. Purifying with fire and electricity, the Great Convergence. This is where the story comes back together. That 30% pure sulfide mix has to catch up. We've done the acid baths, we've done the bubble baths, now we have to purify it with fire and electricity. To strip away that remaining 70% of junk, the raw froth goes through what's beautifully described as a baptism of fire. Those cold, hard rocks we started with, they are now sent into massive blast furnaces and literally melted down into a red-hot, glowing river of liquid metal. Let's track this purity timeline, because it's fascinating. In the first furnace, they mix that 30% pure raw material with 7 layers of special sand. The extreme heat melts the whole shebang, and the sand magically pulls the iron and impurities to the surface to be scraped away, bumping us up to 60% purity. Then it moves to a second furnace, pushing it to 80%. Next, that glowing liquid is poured into rectangular molds to cool into massive copper blocks. Finally, just like the end of the oxide process, these blocks go into long vats of electrified chemical solutions. The electricity strips the copper atoms right off the block and deposits them onto thin sheets, dropping the last impurities to the bottom. The result? Boom, copper plates that are 99.99% pure. Part 6. Shaping our modern world, the final return. Okay, we did it. We transformed a dirty rock into 99.99% pure copper plates. But you don't exactly plug a giant 2-inch thick copper plate into your wall outlet, right? Now comes the final step, turning these pure plates into the everyday stuff we actually use. To do this, those ultra-pure plates get melted down one last time in a vertical furnace. The liquid copper flows down, cast into massive 6-meter-long continuous blocks. While it's still scorching hot, water jets rapidly cool it, and it's fed straight through heavy mechanical rolling wheels. These wheels violently compress and stretch the metal, thinner and thinner, faster and faster, until it shoots out the other side as a continuous 7-millimeter thin copper rod. These flexible rods are the starting point for the endless spools of wire that form the literal backbone of our technological society. So I really want to leave you with this final thought. The next time you grab your phone charger or plug in a toaster or watch an electric car zip by, will you remember the millions of years of geology, those 100-meter deep explosive pits, the weeks of slow acid drips, the bubbling froth, and that extreme baptism of fire hidden right inside that tiny wire? It is absolutely incredible to think that our entire modern world depends entirely on the epic hidden journey of a simple rock. Thanks so much for joining me on this explainer. I hope it sparked your curiosity, and I will catch you in the next one.